Good afternoon, everyone. It's a pleasure to have you all here with us today for another webinar with Jason. Jason is an expert in AI and many other topics in technology, and he has been helping us in the AI for application, AI applications for real estate course, and he brings the more technical and trendy part of the course. So today he's bringing a topic about how different approaches or different uses or technologies of AI can be combined so that AI can work for humans in a level that some months ago it was unthinkable, no? So I'm really excited to hear Jason. Take your time here, Jason. It's a 30 minutes webinar. Uh, yeah, let's see what we brought to us.
Excellent, lovely. Thanks, Felipe. Appreciate the introduction. So, what I wanted to do today is focus on some wider sort of concepts of what we're doing in AI, and also just give you a bit of a hint in terms of what we see coming down the line. Bear in mind, from my projection, obviously we do a lot of training on AI, and also I'm talking to businesses. We're plumbing this in various different aspects. So we work a lot in the real estate industry, but also in legal, financial, technical, as well as actually dealing a lot with software developers in the AI side of things as well. So part of what I wanted to kind of bring is what in the wider scope in terms of how businesses are adopting AI, how they're adopting AI, but also I want to kind of go a little bit beyond, say for example, 10 things that we could do with ChatGPT. I think we all know that ChatGPT and Claude and the like are good tools, but I want to introduce some slightly wider concepts and give you a bit of an idea in terms of where things are going in general. Hopefully you'll find this useful, and of course we can take any questions afterwards. Right, I'm just going to start off, just use the slides as a bit of a guide to go through, and we can also demonstrate some of these aspects as well. What I wanted to really focus on today is the next phase of AI around real estate, and also kind of look at things like, for example, autonomous commerce, which is definitely coming down the line, and also things like the way that chatbots work, etc., etc. Let's dig in. So first off, what we're doing today, we're going to be having a look at really how to process large data sets. That's something that most real estate agents will need to do. This could be rent rolls, or it could be contracts, or anything along those lines really. But again, we see this in wider things, certainly in the financial industries. We're dealing with large amounts of data, and the big question is, yes, we know AI can deal with it, but how can we deal with it securely? So we'll look at the processes and techniques and how people actually achieve that. Nextly, a lot of things that we're talking about at the moment, but actually people aren't too aware of, is an AI agent. We've heard of perhaps even agentic, and of course we're used to the AI tools such as ChatGPT, where we just go in, ask it a question and get an answer. But actually AI is a lot more sophisticated than that, and we're even starting to see agents built into tools that we're using. A lot of people aren't even aware of it. So I want to touch a little bit on what an agent actually is, because we're going to see an awful lot more of them over the next few years. Finally, I just wanted to kind of just touch on something that's very recent really, and I just felt really should do an honourable mention. We're starting to also see AI getting involved in e-commerce a lot more, and I think this is going to really upend the way that so many businesses actually do commercial transactions over the internet. So I thought probably just worth putting something in a mention of that as well, because that might be useful. All right, just to get started, so where AI can help. From a financial modelling perspective, in real estate involves huge amounts of spreadsheets, reports, contracts, rental summaries, market comparable data, leases, valuations, due diligence documents, legal clauses, debt, etc., etc., etc. As we're all probably aware, something like Excel is very much our best friend when it comes to crunching numbers and having large data sets. As is, of course, we might have large contracts in PDF or Word format or something along those lines. How do we deal with those? So where AI can help specifically around those kind of tools, which, let's be honest, a lot of our data is actually going to be using that kind of tool. So it's where we can especially use large language models, or LLMs, is they can help with tasks like summarizing or extracting data. So for example, if we say, what's the escalation clause in a particular contract, it's very good through often hundreds of pages to find out that one specific thing that we're answering. Again, we could say, based on the rental data, give me the projected NOI for the next 5 years. Again, we could look through a very large data set and actually find that answer quite quickly. If there's one thing that we've learned, when it's dealing with human beings, there's the human in the loop factor is always going to be important. But when it's about dealing with large volumes of data and pinpointing that needle in a haystack, as we've probably already seen over the last couple of years, AI is particularly good at that. But how do we actually do that? So where it can help is we can do this safely then. So for example, one of the challenges we tend to see in real estate, we know that we can process large amounts of data quite effectively, but that doesn't necessarily mean that we should take a public LLM and just upload a potentially sensitive data contract or some sort of legal document that might have personally identifiable information. That's the big challenge. So the next question is, how can we combine the AI's power without leaking sensitive information? What we need to bear in mind with a large language model, these large language models are trained with billions and billions of parameters worth of data. Now, of course, the risk is, if we go into your favorite AI tool, let's use ChatGPT as an example, we could start putting our own data in, and of course it's going to start training itself on that data as well. So we need to try and think of a way of which we can leverage those tools, but without the risk of any data leakage. This is the big challenge. So the way that it's most often dealt with is using a process called RAG, which is Retrieval Augmented Generation. And we see this a lot. So even a lot of the larger companies that we're working with and we've talked will not really usually allow access to some of the common tools that we might use in a domestic capacity. We're even seeing, for example, universities have a situation where they're actually locking down the large language models and providing their own. And what they're actually using is quite often self-hosted models, because bear in mind, a lot of the models that we're using online, some of them are actually open source, but we're quite often using retrieval augmented generation as a way to securely ring-fence AI and provide it as a service, but in a controlled environment. So what actually is RAG? Well, we've probably used it without even realizing it, but it's worth being aware. So to read you the definition, RAG is a technique where before asking an AI model to answer a question, you retrieve from your own data source or documents relevant pieces of text, the context, and feed those in along with the user's question into the model, the large language model. This ensures that the model's answer is more grounded and your proprietary data, so in other words the data that we've augmented it with, then this also then avoids having to ingest all the data into the model itself. So in other words, what we're actually doing is, if you think of the large language model as the big brain in the cloud, we could then augment that with some of our own data. So think of it as almost running a small search, finding the most relevant data from our local data source. That will then go into a highly optimized data format called an embedding. That will then go along with our prompt. So it effectively means that when your large language model is processing and coming back with our answer, it's able to use the data that we've also fed it as well in a secure format. Just to try and visualize that, it might look something like this. If you could imagine the user query then is, say, for example, asking a question, say, what's the projected NOI for the next 10 years? Next thing then is we might retrieve the relevant documents. So think of that as like a local search engine that will be then bringing back the documents or the content of which we want to use within that response. That contextual data then is then augmented along with our prompt and sent to a large language model. The large language model will then process based on what it knows and more to the point of what we've just told it, that contextual data, and ask for a response based on that. So it's actually quite an effective way of dealing with a large amount of data and bringing that into the context. Otherwise, what we'd have to do is find some way to upload all of that data into a large language model. Now, first of all, that's going to be a very inefficient process because there's going to be potentially way more data up there than it's going to need to know. But more to the point is we risk actually getting that data inside a large language model, which is really not what we can have. So how that actually works is quite often we might be then using the large language model in different capacities. Now what we can do with the large language models, and again I'll use ChatGPT as a very easy example for this, is we can use something called an application programming interface, an API. Now we know that if we go to something like, for example, ChatGPT, we go to a web browser, we log in, we ask it a prompt and it comes back with an answer. But the reality is applications like that, in fact most services that we take for granted, another good example could be even something like Google Maps, will also have an API. The API allows us to use that same service, but in effect behind closed doors. We can just use it as a data gateway. So truth be told, if we've all got something like this, which is a mobile phone, any of the applications that we use on that phone is going to be using APIs to push and pull data up to the internet. For example, if you've ever worked how, for example, the Facebook app or Google Mail app works, they're just going to be pushing in data down to your device using an API. In fact, truthfully, most software applications that we now know, where we see something that says AI enabled, the reality is it's probably going to be using the API of one of the large language models. So in truth, we can just do the same thing. Now there's a big difference then with the API. It means that we can leverage all the power of a large language model, but none of our data gets ingested. In fact, we can even check this by looking at the terms and conditions. Then you'll find that actually contractually, none of our data gets ingested via this route. So we do have that advantage. However, some companies are taking a slightly more risk-averse approach, which is understandable. So just to give you a bit of a comparison then, if we're using that sort of technique, this is how it kind of stands side by side. So for example, what we might want to trade off is if we were going to use RAG, which we know will very sufficiently support large amounts of data and process it, what are our trade-offs? So for example then, in terms of if we were using something like Cloud API or something like that with ChatGPT or Anthropic or something along those lines, what we could do is we could use something like the ChatGPT API. The pros are easy to adopt, we can have all our data sent up there, but we do have a very slight risk of data exposure, especially if we're using something like compliances, that kind of stuff. Then we could then use something like a hybrid approach, which is using RAG. So effectively, we're only retrieving the context using our large language model. That's then been sent up. And again, we've got slightly better risk there in terms of how much risk is there in terms of our data being ingested by the large language model. But we do get the performance benefits, and we got less risk because we're going to be uploading less data. The first one that would be, say, for example, uploading all of your data in something like a spreadsheet or something along those lines, which in my opinion is probably not the best approach to take. The last approach is what we tend to be seeing quite a lot in the industry at the moment. So, for example, this is where we might be downloading our own large language models or hosting them in our own cloud, but effectively we're running it. Now, this is a big trade-off because here we have ultimate security. We're not connected to a public large language model. We're not using ChatGPT or any of those services. We are running our own large language model. Now, there's one thing to notice here is that's actually quite achievable. There are tools like, for example, Olama, which we can use to just download a large language model and run it completely locally. In fact, I will show you exactly that working. It does mean that we have complete control over our data, what data goes into it, and it means that we don't have any risk at all of any of our data being exposed in a public large language model. In fact, I'm seeing this a lot with universities and large organisations are using exactly this approach. The big trade-off there, though, is, I guess, cost. Because, for example, if you're using, again, you'll use ChatGPT, if we're using something like a $20 subscription a month, the trade-off in terms of actually then hosting it yourself, there's a lot more cost involved. But you do get the security side of things. The other thing to worth notice is that you tend to find with the models themselves, which be using RAG, we've actually got two parts to a large language model. The first thing we've got is the processing power in terms of thinking, coming up with computational results, that kind of thing. So we have that side of things, if you like. The next side is the actual knowledge, so the amount of parameters that each of those models has been trained on. When we actually look at a large language model, the more data that they've been trained on, the larger they are. So they can actually take up a very huge amount of disk space if we're downloading one of these. However, the processing and reasoning power, truthfully, is much smaller. So what you tend to find is if we're using something like retrieval augmented generation with our own data, actually, we don't need that big an LLM. We don't need all that pre-training data because the chances are really what we just need is a very small model that's very good at reasoning. We're going to be supplying all of our own data ourselves. So actually, in terms of disk space, you'll be surprised how small a model you can get away with to come back with really good results. So where is it good for? Well, you tend to find then things like an internal knowledge, chatbots, that kind of thing, or chat bases, we're seeing this an awful lot. If you've ever looked at Notebook LM, which I recommend you do, it's a fantastic tool where we can input videos, text, content, anything we want. It will then index it. We can then ask it questions. So it's a brilliant way if you're ever doing training or just want to be able to analyze large documents. We use a lot for training, for example. We can put meeting recordings in there, all sorts, and it's a great way that rather than having to watch it all back, you can get straight to where you need to. How does it work? It's using this exact technique. It's using that same retrieval augmented generation to index all of that data so that we can ask it simple questions. So again, personal AI assistants, we're now starting to see these built into our phones. Again, they're just using a simple kind of RAG system in order to work. Customer support agents, if you've got a problem with your broadband or anything along those lines these days, we'll go to a chatbot. The chances are that chatbot is pre-trained on some data, and it will be the knowledge base in which it's then having a best guess to try and answer that question. How does that work? Again, it's using something like RAG. And likewise, if you're a software developer, how does it index all of that code? It could be millions of lines of code to try and work out what's what within the application. It's using exactly the same technique. So what I do want to show you then is a quick implementation. I'll just give you a visual implementation first. This is a website where we've actually built a RAG search engine. Now, the RAG search engine on this is effectively, it's indexed every article, all the pages on this website. I'll show you this because it's a nice visual example, but actually you could apply this to any type of business. We're starting to see this again on property websites. I wouldn't be surprised if we start to see this on the likes of Zoopla and Rightmove soon, where we can ask it questions and it will ask it results. But we can talk to it in a conversational format, and that's the example. So for example, if I ask it a question like, do you build websites? Let's ask it that question and we'll see what it comes back with. So straight off you can see it thinking, and it should shortly come back with the results. Okay, so you can see it's basically come back with a result and it's answered that question based on what it's found on the website. Also, if we look down here, you see the sources. And what it'll actually show you are the 5 pages that it's used in order to make that contribution, that opinion, and answer that question. Now, also I've seen this on property websites, we're starting to see this on e-commerce websites, but truthfully, it doesn't have to be a website. I've also seen this done within file systems. You might have a process that will go through and crawl through a file system, open up any documents and start to index them. So we're starting to see solutions where even someone could go into an application and just say, where's my contract for Jones, and show me any documentation around this process, and it should just find things quickly. There is an important trade-off I want to show you though. What I want to do is just show you the back end of how this works. And this here is using exactly the same tool, but effectively without the user interface. Now what I'm going to do is I'm going to ask it a question. This is using the hybrid approach. So what this is doing is this is using retrieval augmented generation, but it is using ChatGPT behind the scenes. Now specifically, what I want to demonstrate then is the speed. So I want to show you a demonstration of this working with ChatGPT, but I'm also going to run exactly the same code running locally on my machine, disconnected from the internet. Just to get started, as a benchmark, I'm just going to run this query, and this is going to be using a retrieval augmented generated system, but we're using ChatGPT. Okay, so that's taken 5 seconds. In fact, I wouldn't mind betting if I run that again, it will probably be slightly quicker. There you go, 3.5 seconds. So that's sort of the speed that we'd expect. One thing I will say with this particular system is it will harvest all of the results and then send them down. The way that usually if we're using an AI tool would work, we all see the whole idea of each word coming out word by word. Sometimes we just assume that actually it knows the answer and it's just going to give you word by word just as a visual effect. The reality is actually quite different. The reality is it's actually working out statistically what the next word should be on the fly. So the truth is, it doesn't actually know what the whole response is until it's finished. So the whole idea of getting everything word by word, that's actually how the LLM is processing it. So it's not a visual effect, that's actually how it works. So the reason I say that is this is why this would have probably taken slightly longer than we might expect. One of the reasons that we all consider AI to be so good is the sheer speed. And that's my point. Next, I'm going to run exactly the same software, working exactly the same code, works in exactly the same way. The difference is it's running on my local machine. Now, for transparency, the local machine I'm running on is a 6-month-old M4 processor MacBook Pro. It's not a slow machine, it's fair to say. It's got a modern ARM processor, it's a quick bit of kit. So it should be a lot faster, right? Okay, well let's see. So let's run exactly the same thing locally. This is not using a public LLM. Yeah, so hope everyone's having a nice day. See the weather's good. Yeah, it's looking quite sunny outside. Yeah. Anyone doing anything nice today? Yeah, this is awkward, isn't it? Yeah, you're probably starting to get the picture. So imagine if the sort of processing power that we'd need in order to run this. So, for example, yes, we could run it on a local machine, that sort of thing, but it would need to be a pretty beefy machine in order to run that. So the chances are we'd probably be putting this into some sort of cloud infrastructure. There we go, 39 seconds. So that was exactly the same query, same code. The difference is it's running locally. You'd think it would be quicker, right? Because it's running on a local machine. We don't have all the latency of connecting to the internet. But actually, as you can see, the reality is quite different. So that's my trade-off. We could totally run this kind of thing, completely ring-fenced, ultra secure, but our big trade-off is speed. And the amount of power that we take for granted with these large language models. Suddenly, when you see an example like that, it suddenly makes you realize just how much power they need, why there's so many water cooling issues, building data centers, and the sheer amount of electricity to power the kind of computational power they need that we take for granted now. It just shows you the amount of resource that we really need to get anywhere near the sort of speed that we've come to take as normal with large language models. Okay, hopefully that should give you a bit of an idea of the trade-off. Okay, so final thoughts on that one. RAG gives us a way to ground AI models. We can then use RAG with ChatGPT, OpenAI. There are various different ways. You will find most, not all, of the different large language models will have an API. ChatGPT, I would say, is certainly one of the easier ones to use. Definitely something to consider then if we're dealing with large data sets that we need to process using AI and we need highly confidential or risk-averse models. Again, we can always start something small. Let's talk about agents. So what is an agent? So I want you to think of an agent as really like a helpful digital assistant. So it doesn't just answer questions. If you think about ChatGPT as our example, we ask it a question, it gives us a simple answer. It's what we call narrow AI. I want you to think of an agent as being a layer above that. Think of an AI process that can actually reason and control different processes. So think of it as a brain. So for example, if we might use an agent then to interact with any of the different services here. Let's imagine we've got a REST API or some sort of data source. It could be something like, for example, the Companies House Companies House Gateway if we want to get company data. It could be a tool that we might use to get hold of documents in our organization or connect to a database. It could be a file system. It could be a connection up to our local CRM or content management system. Most commonly though, it could be a different AI model. So think of an AI that will orchestrate other processes that could also be AI. So let's imagine we might then use an agent. In fact, if you want a really good example, if we go into ChatGPT at the moment, you might notice within the last 6 months it's changed slightly. We ask it a question, and if it doesn't know the question, it goes out onto the internet. Truthfully, we'll now find that there's actually a small agent built into ChatGPT. It's actually overseeing that process, and when we ask it a question, it's deciding which process to use. For example, it doesn't matter if you're going to be then looking for something on the internet or using it to generate a picture of your cat in a flying suit. Either way, you're going to ask that prompt to ChatGPT. It will then orchestrate that process and work out how it's best to do it. So it could be, if you're looking to then build up an image model, it will then call a different process to do that. If it doesn't have within its training data the answer to your question, it will then fire off a different process and say, I don't know the answer. Can you search the internet, get me the best results? We'll then bring that back. I will then look over everything and then provide the answer based on the results that I get back. So that really is what an agent will do. It orchestrates all the different events, different data sources in order to give you the contextual answer that you're looking for. If we're going to visualize that, it looks something like this. So the user basically asks the agent, the input will then interpret that question, plan, work out how it's best to achieve it. Now ultimately what an agent will then do is invoke some sort of an external tool. That could be an application, it could be another AI, whatever it needs to get that job done. There was a good example last year of an AI agent being built to build a podcast. So you could give it a simple prompt, it will then work out the best thing to do. It will then say, right, okay, in order to build a podcast, I'm going to need to write a script. So it will then invoke a process to write the script, give it to the user confirms it, change it, at which point it can then use a service to go off and create the voices. It might use a service like 11labs.com. 11labs, it could then pick a couple of voices, give it the scripts and say, there you go and give me a male presenter, go and give me a female presenter. The AI agent knows that it needs to wait for that service to finish in order to move on to the next step, which is to take the audio and then start to edit it all together so that the two voices are talking to each other. Finally, maybe we should give it a name and some branding so it could use a different service to go off and create the logo for that. In the end, we end up with a fully edited podcast, all the imagery ready to go. And we could even use a process to deploy that and put that on Spotify. But the point is, like any kind of project, we know that things need to run in a set order and some tasks are going to be dependent on the completion of others first before they can be progressed. This is exactly the sort of thing that the agent will orchestrate for us. And those external tools could be, for example, using ChatGPT or an AI tool as much as any sort of external data source. But ultimately, it's all about gathering that information, taking it into the context, reasoning, and sending back a relevant response. Let's look at MCP. So MCP is Model Control Protocol. Now, when we talk about tools, that's really where MCP comes in. So it's a protocol that we can effectively take whatever data source we need or whatever service that we need, and then we can wrap it up with something called MCP. MCP effectively makes it available to an agent. We can tell it what this service does. We can have a simple MCP tool set up that will connect to our CRM, for example. We can expose two methods, and we can say one is search for a customer and get their records. The other one is create a new opportunity and put it into our system. So we can make that available as a tool to our agent. So our agent decides if it needs to get a customer from the database or create a new opportunity, it knows what tools will do that job for it. Let's look at some use cases. We could use that for property deal analysis. We could use that for portfolio monitoring, risk detection. Again, because we can pull in external data sources like companies' house data, financial information, that's all totally possible. It's very development friendly, and we then find also investor reporting automation is somewhere we're seeing this kind of tool used as well. So we could then break that down. So let's imagine a agent and MCP workflow. So without an agent, we might have to gather basically our comps, build an Excel model, check a rental yield, calculate the IRR manually. That could take time. What we could do is we could start to build that down into using an agent and MCP. So this means that then we could take an internal deal spreadsheet template, we could look at land registry data, we could automate looking at the Rightmove API to get property data, we could look at a cost database, interest rate feed, and we could pull all that data in. Within the workflow, it will then know that we need to upload the brochure, AI will then extract the price, square footage, etc. We can then call MCP tools to do the work for us. So we could pull comparable sales, pull the local rental averages, and then fetch the rates. We could then populate the financial model, build our outputs, and then ultimately then generate our commercial impact off the back of that. These are all the sorts of tools that we could use using this workflow, and again, the agent would ultimately control that flow for us. Quick takeaway then, if we want to really simplify the work of something like an agent and using MCP, we want to think as the large language model then as our brain. We might think of the agent then with a brain with autonomy, so in other words, it's able to make decisions and then move off some of these processes to external tasks. Your tools, think of those as the hand, and MCP really is the nervous system. So that's the thing that connects it all together. That allows then your brain to understand exactly what all those processes are available and what they can do and what inputs they'll need in order to facilitate their job. Just to recap then, I know I've not got an awful lot of time. I just want to kind of make you aware of a couple of things that we're seeing a lot in the industry that will almost certainly have an impact on, I think, all businesses in time. We got two big protocols slogging it out at the moment. So we have Agentic Commerce Protocol and we've got UCP, which is Google's offering. So basically these are open standards for programmatic commerce flows between buyer and AI agents. So in English, we're fast getting to a situation where we can do transactions online without ever having to touch the website. So let's imagine we get to a situation where we can effectively unlock the back end of our website. Let's imagine we've got something like an online shop or even a booking or ordering tool. Effectively, we can make that available. We can make that available via the open protocol. So it means that then any tool that just needs to put through a transaction, find a product and buy for it and pay for it, can do it without actually having to go to the website. We're starting to see early signs where the way that it's going to go is we could just sit there within our favorite tool. Again, I'll use ChatGPT as an example. Search for things that we want to buy. It'll be able to do all the transacting within our tool. We never actually have to leave, go to the website, put our payment details in. We're getting to a point where actually this can be completely fully automated within any tool. We don't actually even have to be in the side of the website. So it's fair to say that I think this is really going to change the industry in the way that this works. So looking ahead, I think that's the same slide, sorry about that. They basically enable then digital commerce to be completely interoperable. It also then allows buyers and sellers to transact across platforms, separates commerce logic from the market ownership, And again, it means that we can just start to open up all of our websites. We can transact across any of these platforms. I think the other thing that's going to be quite interesting about this, and it's interesting to see Google and OpenAPI slogging this one out, is the fact that in theory it could disconnect commerce from the main platforms. And by that I mean, for example, eBay, Google Shopping, and obviously Amazon being the big one. What we will definitely see is a whole idea of people just being able to transact completely through AI. Think of that if we then start to put that into an Internet of Things context as well. That will totally be possible as well. Of course, we're already starting to see that with Amazon, where we can just shout at your Amazon device and get it to order your favourite socks for you. So basically, once they're all up and running, the seller then would list your products on your own site. The buyer searches via any compatible app or platform. The order's transmitted via the open protocol. Payments and logistics all happen behind the scenes for you, and it's all transacted. We never even have to go to the website at all. So the takeaway, your website becomes part of a larger commerce network. You can sell products and services across platforms without actually having to rebuild anything. And your buyers discover your products from pretty much anywhere that supports that open protocol. This then, again, reduces the marketplace dependency. We're certainly seeing this out in the industry that people are getting quite fed up of being tied to using Amazon Marketplace or similar. Okay, that kind of wraps up for today. Hopefully that gives you a bit of an insight. We're definitely going to see a lot more of agents in the future. I can certainly see us set into a situation where we're going to start to see public agents. Let's imagine you're looking for a trip away over the weekend, you want something that's family friendly, and you've got very specific things you want to do. I can see us quickly getting to a situation where pretty much everything can be transacted via AI. In terms of looking for booking flights, travel, accommodation, the tools then would be MCP agents owned by, for example, Skyscanner, Booking.com, etc. We're already starting to see Airbnb moving into the MCP market. I can definitely see a lot more automation around that going to be in the future. We're very early stage at the moment, but I think that's definitely going to be the next stage. Okay, I think that wraps me up for today. Any questions at all?
Thank you, Jason, for this webinar. Let's see if anybody raises their hand or writes a question here in the Q&A. Well, just to mention that what Jason brought here is related to the course that we offer, the AI application for real estate. And if you're interested in knowing more about how to apply these tools and other tools in real estate, you feel free to reach out to us and we'll be happy to explain more about the course. Okay, so I think there's no question here. Well, if there is any other question, send us a message and we'll be happy to clear your doubts, right? Any final word, Jason?
No, I just thank you for having me. I really enjoyed that. Hope everyone found that useful, and hopefully the next time we're looking at an AI-enabled search, we'll have a better idea of what's actually happening underneath the hood.
All right. See you soon. Bye bye.
All the best.